Today we're going to talk about object-oriented programming. A good analogy for object-oriented programming is sort of that you're creating a some type of object that has an interface, like, for example, a car. The interface to the car are the acceleration and the brake pedals and the key, but you don't actually put your hands in the engine itself to manipulate it. You use an interface, and the object has internal variables or structure that are abstracted away. So we'll start with making a class. We'll call it a family. No, get a better example. We'll call it We'll call it a car. Now what I've typed in there is the reason I typed in object there is I need to make the object class a superclass of car. Now I can make a subclass of car, but we'll get into that later on. So the first thing we'll need to do is we'll make a constructor for something to initialize it. So a car would have like an age. First, all functions within a class require the self argument in Python, and then maybe we'll say like age, serial number. We'll leave it as that for now. Now, the basic way to interact with some type of class is we have what are called mutators and accessors. So first we'll make a mutator. And then we'll make a getter or an accessor. So what we've done so far is that we've created a basic car object. Oh, first of all, almost forgot. It's good convention to capitalize all class names. So we'll see what we can do with this code. And then in order to create a car, we fill in the arguments for the constructor here. We'll say it's 5 years old and the serial number is a made-up number. And then we can use the interface we created. See there, it's We created a car with an age 5, serial number 1002, and then we used one of the interfaces and then we printed what it returned for getting age. We can also use the same object and set the age. We put 14 in there. And see there, it's changed to 14 after we construct it from 5. Now to say that you, you know, you're working for a company or something, and or an API would be a better example. This car API, and you need to change the functionality in some way, like. So, for example, we'll create a subclass of car, and we'll call it new car. And we'll put car in there. So the reason, what I was talking about earlier, the reason we put object in there is because there's sort of an old style. The object in the car, because there's an old style of classes for Python, there's a new style. From the new style, you need to explicitly set that car as a subclass of object, or else we can't create a subclass of car. Well, we can, but we can't use a keyword called super. You just have to explicitly state the constructor. What we can do now is just like before, and let's say this new car has a personal name for some reason. Sorry. There we go. And that we want to call a, but since it's a subclass of car, we want to be able to use the constructor from car. Now it holds all the same data for age and serial number. We're only adding a new thing by making a subclass of it, of car. So how the super keyword works is we'll type in new car and then self dot two. Also, quick note, there's actually 2 underscores right here and right here for initialize. Yep, that's not good. Okay, so what that will do, whoops. So that will do is it'll call the constructor. I should actually put those in there. And then name. So that will call the super constructor from car in the subclass. And then we'll make some mutators and accessors. Now what we can do, we can also override the older functions. So def set age. What we can do now with this is we can, let's say we wanted the, yeah, we want it by 2. So now we'll try our new objects out. So we'll start with the new one. So it's 14 years old, serial number, and the name is special. Now let's see if this will work. See there, it we overrided the old function. We're able to access the we're able to override the old function instead of it calling the new one, because there's a new one. We'll show an example maybe where it doesn't override. We'll create a new function. This one will return the serial number. As you see there, we can access the old functions, and then we can override the old functions as well. We can even call the old functions just as we call the old constructor with the super keyword. So for set age, we could do just as before. Make a temporary variable over here. As you see there, it returns for get age. It returns the age to this variable right here, and then it multiplies it by 2 and then sets its age. There's another competing way of doing things versus inheritance, because this is what we're using is inheritance. We're making a subclass of a class to be able to expand on functionality. But there's another way of doing things. You can also use what's called composition, where you make multiple classes. So instead of a subclass of new car, it would just be another class called new car. But you have to, a good way of testing whether it's a good idea or not is sort of just to is a test. Is the new car a car? In this case, it is. So it is. It's a good candidate for inheritance. But if it's not, then you might want to look into composition. For classes, you can even you can use other classes to make the class. So before car, I'll make wheels. So we've created a basic class called wheels, and then we'll put them in we'll put a variable in car that holds the object of wheels. So make our basic interface to the wheels. Okay. So let's say we make a method called for car that returns information about the car. So and then wheels. Sorry, done that kind of backwards. Don't make another function. And that looks like it's almost done. Let's take a look. So yeah. So we've created it. So since we're using the wheels object within the car, we can access its method. So this constructor here takes the wheels and then it sets it to hold within the car object. And then we can create a method that interacts with the internals of the car class by interacting with the internals of the wheels class, which is inside the car class. So we'll create a and then we can use the car see there we have some information about the car right here. So now we will try interacting with the wheels now. Take a look. Oh. Tell you, people can program for a while and you'll still make mistakes. But as you can see here, here's the old one, and then we change the tires, and now they're black. We can also interact with the wheels internally. So this might confuse some of you why we're able to interact by just using, instead of going through the car, we'll just directly use the wheels variable. The reason because of that is because objects are sort of like pointers. These variables don't hold the object, they hold a pointer to that object. It's like an address. It's sort of like the objects live at different houses, and the variables are the addresses to the different houses. And since we have the address to the wheels directly, because we used it to instantiate the car object, we can interact with that. And then when the car object looks to go to that same address to change it, it's already being changed. If you understand that. Well, I think that's it for today's video. In the future, I might, well, next we'll probably go over iteration, maybe recursion. And then after that, we might come together and use, combine those two things to sort of make a more complicated data structure, like a binary search tree where you have a class called a node, and the nodes have references to other nodes, and you can search at logarithmic time, and there's all kinds of other data structures and hash. There's a hash map data structure, and in a heap, there's all kinds of other stuff. Well,